The next is the kinetic theory of gases. It's one of the most important theories we have. It's also called microscopic model of gaseous state because that's the only theory which has gone to the microscopic level and has made us understand how these gases behave, especially at a molecular level. It has certain fixed postulates. The first one is that which says all gases are made up of the very small tiny particles which are called molecules, and the molecule of a gas are identical in all aspects like the color, mass and etc. And they occupy a very large volume, the reason being they have very large intermolecular distances, and that is why that makes them what highly compressible. That's the first one. The second one is they have no or almost negligible intermolecular forces of attraction, and that is why they don't have any kind of an affinity between them, and that is what which is not bringing them closer to each other, and that is why they are able to occupy whatever the volume which is given to them. Then they always are in continuous random constant motion and moving from one place to the other, and they always are in constant random motion, and that is called the Brownian movement. Now in these constant, the next postulate is due to this constant motion, random motion, they are always colliding with one another and with the walls of the vessel. And remember, all their collisions are perfectly elastic in nature. No loss of energy takes place, and if this would have happened, their energy would have gone down, and that is why we have found that the molecule settles down, then they would have started settling down at the bottom of the system, but this doesn't happen. So we conclude that all their collisions with the other gas molecules and with the walls of the vessels are perfectly elastic in nature. No loss of the energy takes place in all those collisions. The next, the pressure of a gas is the force with which they strikes the wall of the vessel. That's the most important thing. It has defined that what is the pressure is. It is the force with which they strike the wall of the vessel. So if the higher is the force with which they strike the wall of the vessel, that means the higher the kinetic energy they have, higher with the pressure. Then the gravity has no effect on these gas molecules. It was concluded by seeing that whenever we see, you must have seen in any dark room, from when the sun rays comes, you can see the dust particles moving here and there. So they never come down due to the gravity. So it was concluded that they don't have any effect of the gravity on them, and that is why it is believed that they don't have any effect. Then the temperature of a gas is found to be the function of the average kinetic energy of the gas molecules. Or we can say that the average kinetic energy of the gas molecule is the function of its temperature. If we increase the temperature, the kinetic energy gets increased. Kinetic energy gets increased, they strike the wall of the vessel with greater force, the pressure also gets increased. So all these things, this postulate is most important because this is how it relates the temperature and the energy, and that is what the major formula we get out of it, which is PV is equal to 1 by 3 mnu square, from where we derive that the kinetic energy is a function of the temperature. So these are the major postulates of the kinetic theory of gases.